This is a solution to linear momentum number 2. It's all given in words, so I think it makes sense to first just draw out what's going on. So there's a 10 kilogram mass that undergoes a collision with the floor. Okay, so here's the floor. And this thing comes in, so we have an object just bouncing off the floor. Before the collision, it has a speed of 10 meters per second, 10 degrees from vertical. Okay, so before it bounces, it's on the way down. Okay, and it says that the angle that it makes with the vertical is 10 degrees. And it says that the speed is 10 meters per second. The mass is 10 kilograms. And then after the collision, it's going to bounce this way. And it says that after the collision, the speed is 8 meters per second. And it makes an angle of 12 degrees with the vertical. Okay, so that's what's going on. And the length of the collision is 0.03 seconds. And we want to figure out the average net force and then the average contact force. All right, well, we're going to use that initial speed going down towards the floor as our P1 to calculate P1, and that later velocity coming off the floor to calculate our P2. So P1 is going to be 10 kilograms times the velocity represented by something going 10 meters per second at this angle. Notice if it was going straight down, that angle would be, it would be cosine and sine of 270 degrees. This is 10 degrees into the fourth quadrant, so that would be 280 degrees. So cosine and sine of 280. And so that gives 1.74 negative 9.85. And the units for momentum, you can get it from the way you calculate it, kilograms, meters per second. Okay, so that's the momentum. Whoops, sorry. This is the velocity, right? The speed is 10 meters per second. That's the direction. And now multiply that by the mass of 10 kilograms, and you get P1 is equal to positive 17.4, negative 98.5 kilogram meters per second. Okay, now for the second one, the velocity at that second instant is the speed of 8 meters per second times cosine and sine of, the way I have it here, is 78. So give me a second. 8 times cosine is 78, sine is 78. And so that velocity coming off the floor is positive 1.66, 7.83. And now multiply that by the mass, and we get our second momentum is, the mass is still 10 kilograms. So our second momentum is 16.63, 78.25 kilogram meters per second. Okay, well, the impulse momentum equation says the later momentum minus the earlier momentum is equal to the integral of the force with respect to time, going from T1 to T2. And if we're just trying to calculate the average force, then that F is just going to be a constant. We can pull it out. And so we have 16.63, 78.25, the later momentum, minus the earlier momentum, 17.4, negative 98.5, is equal to this average force times the elapsed time, which is 0.03 seconds. And so the average force vector over that 0.03 seconds is negative 25.67 for the x component, and 58.91 for the y component. $58.91.67 for the y component, and the units here are newtons. And then the second part of that question, what's the average contact force? So the idea for that is just so the during that contact, if the ball is compressed against the ground, you have two forces acting. You have the contact force and you have the weight force. That's 98.1 acting down. And I think the easiest way to think about this is we know that F net, the average net force, that's what this is, the net force on average, is equal to the average contact force plus 0, 98.1. And so you get that average contact force. All you have to do is subtract and you get that the average contact force is negative 25.67. The x component didn't change. The y component did change a little bit, 5989.77. But the idea here is often with these short duration collisions, the force over that small amount of time is so big that the weight force is kind of dwarfed by everything else going on. So you can see, like, percentage wise, thinking of that contact force as being equal to the net force didn't really mess up our answer by a very big percentage, because the contact force is so much bigger than the weight force. And it often is the case that the shorter the duration of the collision, the less important it is to separate out individual things. You can just sort of think of that collision as being almost all of the net force. So that's the solution to conservation of linear momentum number 2.